Okay, so ladies and gentlemen, so let's see how we are going to use SPDF orbitals to demonstrate the group and the period to which an element belong to. So we know that we have so many orbitals. We have S orbital, we have P orbital, we have D and F orbital. So S orbitals accommodate a maximum of 2 electrons, P orbital accommodate a maximum of 6 electrons, D orbital accommodate a number of 10 electrons, then F orbitals accommodate a number of 14 electrons. So these are the number of electrons to which each of these orbitals can accommodate. So according to our principle, is the principles that trying to show how electrons are arranged in the orbitals based on their energy level. So he stated that electrons are arranged from lower energy level to higher energy level. And mostly, if when it comes to this point, I usually make some diagram so that student can easily get it. This is how it is. You start with 1s here, then you have 2s, 2p here. Then here we have 3s, we have 3p, and then we have 3d. Then we have 4s, we have 4p, and then here we have 4d. And then we have 4f. So I usually do this so that students can easily get it. So according to our principles, electrons are arranged from lower energy level to higher energy level. Like for example, this one is start from here, followed by this one, and then this one. It will go like this, and then like this, like this, like this. What does this mean? It means that when you want to start arranging electrons on these orbitals, it means that you start in this direction. You start with 1s, followed by 2s, 2p, 3s, 3p, 4s, 3d, 4p, and then we have 4d, then 4f. So let's see now. Let me take the same sodium. The atomic number of sodium is 11. So then, of course, we start with 1s. So we start with 1s. And s accommodate a maximum of only 2 electrons. So we have 1s2 here. So we finish with 1s. Then the next one is 2s. So still s. So it accommodates 2 electrons. Then followed by 2p, 6. So 2 plus 2, 4 plus 6 making 10. So still we have 1 electron left. So the next one is, after 2p is 3s. So we have 3s1. So now there are a number of things that I want you to understand here. How do we know, based on this electronic configuration, how will you know the group to which sodium belongs to is based on the index number of the last orbital. So the last orbital here is s, and the index number is 1. So that is why it is in group 1. And why is it that it is in period 3? Because of the energy level. The last energy level here is 3. The last energy level here is 3. So that is why it is in period 3. Please, are you following? Do you understand? So that is what we call, that is how we demonstrate the group and period to which an element belongs using orbitals configuration. And I want you to understand, we also have blocks of the element. We have blocks of the element. And blocks of the element, we have different types of them. We have S block element, we have P block element, we have D block element, and then we have F block element. So these are the number of blocks that we have. So element is S block element because the last electrons end in s orbital. So that is why it is S block element. P block element is P block element because the last electron end at p orbitals, because their last electrons are ended at p orbitals. And D also, they are transition element and they have electrons on their D orbitals. And then for the F orbital, the same thing, meaning that they have electrons on their F orbital. So that is what I want you to understand under this. So then the next thing is that, what if we have now, let's say we have chlorine, and the atomic number of chlorine is 17. So to draw the electronic configuration of chlorine, we have 1s2, we have 2s2, then we have 2p6. Following the sum, this 1s2, 2s2, then 2p6, then the next one we have 3s2. After 3s2 is 3p, so we have 3p5. So 2 plus 2 we have 4, we have 10, plus 2 we have 12, plus 5 we have 17. So how do we know the group to which this element belong to? So look at it here. This is 5, this is 5. So chlorine is not in group 5, like as we did exactly here in sodium. So because why? Because the last energy, this last and second to the last energy level, they have the same energy level. So the last and the second to the last orbital, they have the same energy level, which is 3 3. So therefore, to know the group of this element, because last and second to the last energy level are the same, so I'm going to take these two index number and add them together. 2 plus 5 making 7. So chlorine is in group 7, and it is in period 3. And it is in period 3 because it has 3, the energy level is 3. So therefore, this is group 7 and this is period 3. So chlorine is here. So ladies and gentlemen, I will see you next in my next video. Thank you very much.